Chapter 3 is oral medications. So probably the easiest way to administer medications is going to be orally, which means by mouth. And this is because patients can usually swallow solid or liquid forms of medications relatively pain-free. So for this section, we're going to learn how to calculate the amount of medication to administer by mouth. And the abbreviation that we'll be using is going to be this PO. So PO, every time we see that, we should know that that means by mouth or orally. And that comes from, we're going to see a lot of Latin abbreviations. That comes from per os, which literally means by mouth. Okay, so starting by finding the oral medications with identical units. So for most of these problems, we're going to have a prescription, and then we're also going to have the on-hand medication, and we have to figure out how much of the on-hand medication we need to give the patient based on the prescription. So we're starting with the same units here. So example, both are in milligrams. So these are going to be the easier examples when they're the same units, and a lot of the time here we can do some of these mentally. But the way that we can always do this is just like we've been doing these things. We can set up proportions and solve the proportion. So recall a proportion is going to be a ratio equals another ratio. One of the ratio for these problems is going to come from the order itself, while the other ratio is going to come from the hand-on drug. Okay, so let's see an example here. So the physician orders 400 milligrams of magnesium POBID. So we see the PO, once again, we know that means by mouth or orally. That BID, that's an abbreviation. Once again, it's Latin, and it represents twice per day. So that's not going to affect how we do the problem. That's just part of the order here, and I'll come back to these abbreviations in a little bit. So the label on the medication reads magnesium 200 milligram tablets, and we want to know how many tablets should be given. Okay, so hopefully this one's easy enough to do in our heads. We have 200 milligram tablets, and we want 400 milligrams. Hopefully we know just to double that, so it would be 2 tablets, but let's set up the ratio, or the proportion anyway. So the ratio from the order itself is going to be 400 milligrams for X number of tablets. So that ratio comes from the order itself. We're looking for the number of tablets, and that's going to equal the ratio for the on-hand drug. So this is our proportion. We have 400 over X equals 200 over 1. So we would have to solve for X here by cross multiplying. We were going to get 400 times 1 equals 200 times X. We divide both sides by 200. And we get 400 over 200 is 2. So that gives us X equals 2. And then we always need some sort of label here. In this case, we found tablets. So X is 2 tablets, which we kind of did in our head before we even started this. Okay, so a few things that are kind of worth mentioning here. Tablet or capsule strengths are pretty much always given per 1 tablet, even if it's not written. And it's not necessary to recognize the drugs used in these examples. And in fact, some of these drugs in the examples are just straight up made up drugs. And the abbreviations, coming back to the abbreviations that I mentioned, there are a lot of abbreviations used. And on this last page of these notes, let me scroll all the way to the end here. On the last page, I have commonly used abbreviations. So you can kind of scroll through these. I'll be using a bunch of them throughout these examples also. Okay, next examples here. When oral medications are in liquid form, the label is usually going to indicate the strength of the medication, and it's usually going to be in milliliters. And just like before, we're going to be using proportions to solve these. And just a note here, we're going to be rounding the oral medications, the liquid oral medications, to the nearest tenth. Okay, so let's see this example. So the order that we have is chloral hydrate, and we have this abbreviation for it right here. That is going to be 7.5 grains. And then once again, we have PO, which means by mouth. So this is 7.5 grains. And for what we have on hand, we have chloral hydrate labeled 10 grains per 4 milliliters. So we want to know how many milliliters should be given. So obviously you need to remember how to what all these abbreviations mean, especially with the Roman numerals. Once you kind of write it down in your plain English with the Hindu-Arabic numbers, it becomes a little bit easier. So we want to know how many milliliters should be given, so let's set up this proportion. So here is the ratio from the order. It's 7.5 grains for how many milliliters. We're looking for milliliters for this, so that's why I put X down there. And now this is going to equal the ratio for the on hand. So that one equals 10 grains for every 4 milliliters. And then we double check, make sure the units are the same on the top and then same on the bottom, which they are. So we can solve for X once again here by cross multiplying. So cross multiplying, we're going to get 10x equals 4 times 7.5, which is 30. Divide both sides by 10 here, and we get 30 over 10 is 3. So our answer is 3, so let's just write it separately with our units, and this is 3 milliliters for our answer. Okay, so let's do a couple more examples here. The physician orders 75 milligrams Imuran. The Imuran label reads 50 milligram tablets. We want to know how many tablets should be given. Okay, so once again, let's set up a proportion. So we have the order ratio on the left, 75 milligrams for how many tablets, so 75 over X, and that's going to equal the on hand, which is 50 milligrams for every 1 tablet. So let's cross multiply here, and we're going to end up getting 75 times 1, which is just 75. 75 times 1 equals 50 times X. And then we divide both sides by 50. And we get 75 over 50, which is 1.5. So 1.5 equals X. And then as the final answer, that is tablets. So that's going to be 1.5 tablets. Okay, and let's do another one here. We have an order of 0.125 milligrams of Lanoxin elixir, and the on-hand medication that we have is 0.05 milligrams per milliliter of the Lanoxin elixir. So we want to know how many milliliters should be given. Okay, so setting up this proportion once again. We have the order ratio, which is 0.125 milligrams for how many milliliters, X milliliters, and that's going to equal 0.05 milligrams per 1 milliliter, which is the on-hand drug that we have. So that milligram per milliliter, you just have to know that when it says per milliliter, that's referring to 1 milliliter. Okay, and then easy enough, once again, we just cross multiply, 0.125 times 1, so we get 0.125 equals 0.05 times X. Divide both sides by 0.05. And we end up getting 0.125 divided by 0.05. That gives us 2.5 for X. And this is in milliliters. So X is 2.5 milliliters. Okay, so for the next thing here, we're just going to get some practice in reading drug labels. So usually on drug labels, it's pretty cluttered with information. So what we're going to do is kind of weed through all of this words and numbers and find the information that we need. So for these oral medications, what we're going to have to do is find the strength per dosage of the given medication. And for solids, the strength per dosage is going to be the number of milligrams, grams, or grains, etc. that are contained in each tablet, capsule, or pill. And then for liquids, the strength per dosage is going to be the number of milligrams, milligrams, grams, or grains, etc. once again, that are contained in a given number of milliliters. So for solids, it's going to be a tablet, capsule, or pill. For liquids, it's going to be a given number of milliliters. And we'll see that some are going to be pretty easy to read, while others are going to be a little bit more difficult. So let's just do several examples here. So let's find the strength per dosage on the following labels. So for this first one, clearly we have a lot of information here. So we have each tablet contains 60 milligrams, and there are 30 tablets in the full bottle. Okay, so hopefully simple enough for that one. Let's do another one here. So we have 2.5 milligrams per tablet, and then we have 7 tablets in the bottle. Okay, and then for this next one here, for the strength per dosage, we have 200 milligrams per 5 milliliters. So what that means is 200 milligrams are contained in every 5 milliliters. And for this one, it doesn't look like it tells us how large the bottle is. And for this one right here, we have 12.5 milligrams for every 3 milliliters. And then I also jotted down here that there's 5 fluid ounces in that full bottle. Okay, so once you find the strength per dosage from the drug label like we just did, we can calculate the correct dosage to give to the patient just like we did previously. So let's do this example here. So for example, if the physician orders 650 milligrams Hypodream PO, so once again by mouth, and using the drug label below, how many tablets should be given? Okay, so first we need to find the strength per dosage on the label here. So we have 325 milligrams per tablet. We know these are tablets because, well, 1, it says it in the question, and 2, it's written on the label there. Okay, so once we have this piece of information, this is essentially our on hand. We can set up a proportion just like we did before. So we have to take into consideration the order, which was 650 milligrams. So setting this up, we have the order ratio, which was 650 milligrams for X number of tablets, which is what we're looking for. And that's going to equal the ratio for the on-hand drug that we have, which was 325 milligrams for every 1 tablet, which we found on the label. And now we have to cross multiply and solve this for X. And we end up getting 650 times 1, which is 650, equals 325 times X. Divide both sides by 325, and 650 divided by 325 is going to give us 2. So we get X equals 2, and our answer is tablets. Okay, so this is one we probably could have done in our head also, which would have been fine. Let's do another one here. So the order we have is this WAGS solution, and this is going to be 43 grains. So obviously we have to be comfortable with the Roman numerals still. That's 43 grains by mouth. So using this drug label below, we want to know how many milliliters should be given. Okay, so finding the strength per dosage on the label, that is right there. And that's going to be 10 grains, so Roman numerals 10 grains for every 5 milliliters. And let's set up this proportion with what the order was. Okay, so we have this proportion now. It's 43 grains for X milliliters, where we're looking for the X. That's going to equal the on-hand drug that we have, which was 10 grains for every 5 milliliters. So cross multiply and solve for X here. 43 times 5 is 215. 10 times X is 10X. Divide both sides by 10. And we get X equals 21.5, and our answer is in milliliters, so that's 21.5 milliliters. Okay, so far that was essentially all of the same thing. We had identical units, so we just had to set up the proportion properly, cross multiply, and solve for the variable. So now we're going to be doing oral medications using units that are not identical. So when we have units that are originally not identical, what we have to do is convert one of the units to the other one before calculating the correct dosage to give to the patient. Okay, so let's say the physician orders 0.25 grams of Keflex by mouth, PO. The Keflex label reads 500 milligram tablets. We want to know how many tablets should be given. So let's start to set up a proportion here, and then we'll see the issue with the units being different. So here's how we would set up the proportion if the same way that we've been doing it. We have 0.25 grams for every X number of tablets, which is what we're looking for, and that's going to equal the on-hand of 500 milligrams for every 1 tablet. So the issue here is this is not the same units as this one, right? The units have to be the same. We have grams and then we have milligrams. So what we have to do is we have to change one of them. So what I'm going to do is you can change either one. I'm going to change the 0.25 grams into milligrams. Okay, so what we can do is you can create your little table here, a little row of the metric measurements. So we're starting with grams and we're going to milligrams. So that's going to be 1, 2, 3. So that means we have to move the decimal 3 spots to the right to convert that to milligrams. Okay, so what that means is that 0.25 grams is going to equal 250 milligrams if you move the decimal 3 spots to the right. So taking a look back up at our proportion, now we can replace 0.25 grams with 250 milligrams. Okay, so once we have this new proportion set up down here, we double check, make sure we have the proper units, which we do. They're both milligrams in the numerator and tablets in the denominator, so we can cross multiply and solve for X here. We get 250 equals 500X, divide both sides by 500, and we get X equals 0.5, and we can write that as a fraction, which is X equals 1/2 tablet. Okay, let's do some more examples. Okay, for this one, we have an order of codeine, and it's 0.5 grains or 1/2 grains. And we have PO and then Q8H. The Q8H means every 8 hours. The QH, as you'll see in the abbreviation on the last page, means every hour. So Q8H is every 8 hours. Okay. And the on-hand that we have is codeine 15 milligram tablets. We want to know how many tablets should be given. So let's set up this proportion once again as if the units were the same, just so we can get a start to it. Okay, so this is how we would set up the proportion, but we realize that the 0.5 grains and the 15 milligrams are different units. so we can't set it up this way. So what we're going to have to do is either convert 0.5 into milligrams, or we can convert the 15 milligrams into grains. So what I'm going to do here is I'm going to convert the 0.5 grains into milligrams. And to do this, we need the conversion. So we can use a proportion, we can use the dimensional analysis method. I'm just going to set this up using dimensional analysis. So the conversion is that 60 milligrams equals 1 grain. So we're going to multiply 0.5 grains times 60 milligrams over 1 grain. And this is the dimensional analysis approach where the grains are going to cancel. We're going to be left with 0.5 times 60, which is 30, and the units of milligrams remains. So 0.5 grains equals 30 milligrams. And now we're going to replace that into the proportion, and we're going to end up with this. 30 milligrams per X tablets equals 15 milligrams per 1 tablet. Once we have the units correct, now we can just cross multiply, and I'll just pause it and skip to the answer here. We should end up getting X equals 2 tablets. Okay, in this next example, we have an order of 0.3 milligrams Krug's Elixir PO, and then the on-hand drug that we have is going to be 300 micrograms for every 10 milliliters, and we want to know how many milliliters should be given. So let's set up the proportion just like we normally would. Okay, so this is what the proportion would look like. We have different units in the numerators. So we can't do it this way. First, we're going to have to either change 0.3 milligrams to micrograms, or we have to change 300 micrograms to milligrams. And I put a little note at the top right. Just recall that the MCG is one abbreviation for microgram. You also have the mu symbol, and then gram is another one. Okay, so let's convert the 300 micrograms into milligrams. Okay, so I wrote down the metric, the little row for converting in the metric system down here. So we're starting with the micrograms and we're going to milligrams. So that's going to be moving the decimal over 3 spots to the left. So if we start with 300 and we move it 3 spots to the left, that will give us 300 or 0.3 milligrams. Okay, so once we have that, we can just set up that proportion again, except replace 300 micrograms with 0.3 milligrams. So we end up having 0.3 milligrams divided by X milliliters equals 0.3 milligrams over 10 milliliters. So hopefully you don't even have to do any work to solve this one. Hopefully it's pretty obvious that our answer is 10 milliliters because both of those numerators are the same. Those denominators then have to be the same also. So if you didn't recognize that, you would just have to cross multiply and solve for X. Okay, let's do about 2 more here. So we have that the physician orders 0.75 grams of tetracycline, and the QID abbreviation is 4 times per day, and the tetracycline label reads 250 milligram capsules, and we want to know how many capsules should be given. Okay, so setting up this proportion. So we have 0.75 grams per X capsules equals 250 milligrams per 1 capsule. So we're looking for X, but we notice that these numerators have different units. So we can either convert 0.75 grams into milligrams, or we can convert 250 milligrams into grams. What I'm going to do is convert 0.75 grams into milligrams. And to do this, we'll write down the metric system conversion. And notice I just leave, if I'm not using micrograms, I just don't write it out. You can write it out if you want, but since I know I'm not using it, I don't bother writing it. So we're starting with grams. So we're starting here, and we're going to milligrams. So that's going to be 1, 2, 3. So we're going to move the decimal point in 0.75 grams to the right 3 units. So that's going to be 0.75 grams. Move it to the right 3 units. That's going to give us 750 milligrams. Okay, so now we can set up that proportion again. And hopefully this is one that we can do on our head. We have 750 over x equals 250 over 1. So solve this, cross multiply, and we should end up getting x equals 3 capsules. So I'm just going to skip the writing out the steps for these last two, just because we've done it a million times already. Okay, so let's do one more here. So the physician orders 0.6 milligrams of Synthroid by mouth 4 times per day, and the Synthroid label reads 100 micrograms for every 5 milliliters. We want to know how many tablespoons should be given. Okay, so this one, I put a little hint down here. First, let's find the milliliters to be given. And then we're going to convert that to tablespoons. And then I put the conversion here. 1 tablespoon is 15 milliliters. Okay, so setting up this proportion, we have 0.6 milligrams for x milliliters, which is what we're looking for, equals 100 micrograms for 5 milliliters. So we notice that the units, once again, are different in the numerator. So we can convert 0.6 milligrams to micrograms or 100 micrograms to milligrams. I'm going to convert 0.6 milligrams to micrograms. Okay, so going from milligrams to micrograms, we're starting here, ending here. So that's going to be 3 spots to the right. So we're moving the decimal point 3 spots to the right. So that means 0.6 milligrams is going to equal 600 micrograms. And setting up this proportion again, we have 600 micrograms over x milliliters equals 100 micrograms over 5 milliliters. So we cross multiply and solve for x. We should end up getting, I'm just going to skip the steps again for solving for it. We should end up getting 30, which is 30 milliliters. And now we need to convert 30 milliliters into tablespoons for our final answer here. So you can use a proportion, obviously, or you can use dimensional analysis. I'm just going to use dimensional analysis and say we have 30 milliliters. We're going to multiply that by the conversion, which is given to us in the problem, which is 15, it should be 1 tablespoon for 15 milliliters. So that's going to be canceling the milliliters. 30 times 1 divided by 15, that's 30 divided by 15, which is going to give us 2 tablespoons. Okay, so a couple extra steps in that one, but still very doable. Okay, so that is it for this chapter.